So that was a quick summary of various different interfaces that operating systems provide to our human users for interacting with the system. Now these interfaces which are provided to the users, these are not suitable for the user programs, right? So there is a different set of interface that is provided by the operating system for our programs. So next we'll talk about that. So here we'll talk about specifically we'll talk about system calls and APIs. Before we can dive into the discussion of system calls, it is important to understand the concept of protection in our systems. You would recall from your study of computer organization that every microprocessor has an instruction set. So this is the set of instructions that the microarchitecture or that microprocessor can execute directly without further translation. So these instructions essentially represent the language that the CPU speaks. Now this slide over here shows some examples of such instructions. So for instance, this move instruction over here, this will move a piece of data from a memory address into this register over here. Similarly, this add will add the value that is stored in the first register to the value here in the second register. So likewise, there are many other instructions that are listed here. No need to go into details of all of these. But let me just quickly mention this halt instruction. When executed, this halt instruction will halt or stop the machine. Now what is important for us to understand from the operating system perspective is that all of these instructions can be partitioned into two groups: regular instructions and privileged instructions. Regular instructions are basically those instructions which can be executed by any user program or anybody in the system. Essentially, by executing these regular instructions, you cannot harm the system either accidentally or otherwise. Some examples of regular instructions would be the add instruction, the subtract instruction, the move instruction, and so forth. As opposed to this, the second set of instructions, right, the privileged instructions, we cannot trust the user programs to execute such instructions. Only the operating system can be trusted with such instructions. So for example, halt. This is an example of a privileged instruction. So why is halt a privileged instruction? You see, when the halt command is executed, the machine halts. The machine perhaps shuts down. Once the machine is down, no process can execute on the machine. No users of the machine would be able to access any of the system resources. So executing halt not only affects the process that issued this halt instruction, but also all other processes in the machine. And therefore, we cannot trust any arbitrary user program or user to halt the machine at will. Otherwise, a malicious user, for instance, can use this halt instruction to launch a denial of service or denial of access kind of attack for all other users in the system at any point in time at will. Therefore, we can only trust the operating system kernel to decide when to execute such privileged instructions. Now halt is just one example of a privileged instruction. There are other such instructions that fall in the privileged category that we'll talk about shortly. So essentially, for any given CPU, we can partition its instruction set into two groups: regular instructions and privileged instructions. The regular instructions can be executed by any user program and also obviously by the operating system. However, sensitive instructions can only be trusted with kernel. The problem is the user applications may be buggy or malicious, and so we do not trust them with these privileged or sensitive instructions. So somehow we need to ensure that these privileged instructions can only be executed by the operating system kernel. And therefore the question is, how does the operating system ensure that user applications cannot execute the privileged instructions? If you think about it, basically you as a user, you could write an assembly program that calls, let's say, this halt instruction. So what prevents this halt instruction in your program from executing? So essentially we need something in the hardware to enable this kind of support. And this is where we get into protection.